In this video, we're going to remind ourselves about the Algebra 1 property of solving a system of equations. Now remember, systems means we're dealing with more than one equation at a time. Today we're going to practice using that substitution method. So substitution is just plugging in something for an equal value, or an equal letter in this case. So if we look at my two systems in part A here, we have y equals 7x minus 10, and we have y equals negative 3. So if we already know what y is equal to, I'm just going to go ahead and plug that number in for y. So we get negative 3 equals 7x subtract 10. And now we're ready to solve for x. Get 7 equal to 7x, and x is equal to 1. Now, when we're solving equations, though, you might remember that we don't want to just solve for one variable. We want to solve for the solution of where this is going to occur. So we're going to write this as a coordinate, and that coordinate is going to be when x is 1, y is negative 3. We know that because right here in that second equation, we already were told that y was equal to negative 3. So anywhere that these can meet are going to be that solution set. It's going to be a little bit different in part B because now we don't have y equal to a constant. Instead, y is equal to this whole 3x minus 20. But y and y are going to be equal to one another, so we're going to plug in. So what I mean by that is wherever y was, I'm going to plug in that y value that we have, this 3x subtract 20. One thing I want to make sure not to do is I don't want to forget to distribute. So I should have 4 times 3 is 12x, subtract 80, and then we can bring the rest of this down. So what we want to do next is just solve for x. Combine like terms, we'll get 13x. I'm going to add the 80 to both sides to get 65. And when I divide by 13, we get x equal to 5. Same as before though. We don't want to just leave x by itself. We're going to find what the y solution would be when x is 5. So I can plug into either one of these equations, the top or the bottom. I'm going to plug into the bottom because it's already got y set up by itself. So 3 times 5, subtract 20. Y is going to be equal to 15, subtract 20 is a negative 5. And just like before, we'll write it as a point, 5, negative 5. So that would be our solution for those two equations. Now, it's even nicer when it's on a graph. So even though we're switching up our equations to be f of x for the circle and g of x for the line that's indicated, the way we figure out what the systems of equations, their solutions are, is just by figuring out where they intersect. So in this case, we have two solutions there. We have the point 1, 2, and the point 3, 5. Circles and lines are funny like that. There's a couple of different scenarios that could happen for each time we encounter them. So when we solve a system of equations with a circle and a line, there's 3 different solutions that could happen. So imagine that I have a circle, and we could have exactly what just happened. That means I have 2 intersections, which means I have 2 solutions. You might recall from geometry that I can also have a circle that has a tangent line, meaning it only touches once. And that means there's 1 solution. Or you can have a circle and a line that never touch. So we would have 0 solutions in this case. They never intersect. The reason why 2 is our max, though, is because we can never have a line that like curves back and tries to start doing weird stuff like this. It's just not possible. Lines can only go straight and they never turn around. There are no curves to them. So they go on forever, but they only can go in one direction. Now we're going to look at some other examples of this. So we have two equations yet again. Now, in this case, y is not by itself on the bottom, but it is on the top. So this whole thing is equal to y. We're going to plug that right in. So we're going to have x plus this whole thing, 2x squared plus 15x plus 9, and it's all equal to 9. So remember, this x and 9 are from the original. Everything else was what was plugged in there. And now we're just going to combine those like terms. So we see that we have 2x squared plus 16x plus 9 equal to 9. But remember, now that we're dealing with a quadratic with something raised to the second power, we don't like to leave that there. So I want to subtract the 9 from both sides. So if I subtract 9 from both sides, I'm left with equal to 0. That 9 is going to end up canceling out. And when I'm solving now, I could use quadratic formula. I could attempt to complete the square. But what's nice is I might notice I can just factor. I have a GCF of 2x, and I'm left with x plus 8. Once I've broken it down to the smallest possible factors, I'm going to set both pieces equal to 0. So 2x equals 0. When I divide both sides by 2, x equals 0. X plus 8 equals 0. And I'm going to subtract the 8 over to get negative 8. So now we have two solutions, but we're not done just yet because remember, we still have to go back and plug in. You can plug into either equation, the top or the bottom. In this case, I'm probably going to just plug into the bottom one, that x plus y equal 9, since there's less work that I have to do when I'm plugging in. But you could always just plug it into your calculator and it's still going to provide you the answer. So I'm going to have 0 plus y equals 9. We know that y equals 9, so my first point is 0, 9. So that was my first solution. And we're going to do it again for the x equals negative 8. So negative 8 plus y equals 9. When I add 8 to both sides, we end up with y equal to 17. And that coordinate is going to be negative 8, 17. So now we have ones that end up with two solutions. Okay. If I keep going with that same idea, I'm looking at two more systems equations. I'm just doing the same thing again, plugging in and just solving. So I want to get one of these letters by themselves. So it doesn't matter if I solve for y or x here. So I'm going to subtract x to both sides. That way we get y equals negative x, subtract 3. Because I now have one of them by themselves, I can plug into this y up here. And that's exactly what we're going to do. So if I had x squared plus, now this whole thing is where I'm going to plug into. So notice I'm keeping the whole shape intact, but I'm plugging in for y. So now I'm going to plug that negative x minus 3 in. Because now if you look at it, I'm down to one letter to solve for. The whole point of this is if I have one letter to solve for at a time, it's something we know how to do. But remember, this is not just going to be x squared plus 9. Do not fall for that trap. This is like having the same exact thing written twice. So negative x times negative x squared. We end up with positive 3x plus 9. So we end up with x squared plus 6x plus 9. And I don't want to forget to bring down everything else that we started with, so the x squared and the 17. So now I'm just going to combine like terms like before, so we end up with 2x squared plus 6x. And if I can even subtract that 17 in the same step, we're going to have a negative 8 equal to 0. Because remember, with quadratics, we want it to equal to 0. from this point, I could try to do completing the square or quadratic formula, but I might see if there's anything we can do. I might be lucky and be able to pull out this 2. So I can simplify by solving by dividing both sides by the 2. So we get x squared plus 3x, subtract 4 equal to 0. And I still couldn't use the quadratic formula or completing the square, but you may notice it's a nice simple AM now. We can have x and x. We're going to have positive 4 and negative 3 from AM. So when I solve, x equals negative 4 and x equals positive 1. So at this point, you can choose which either one of those 2 equations to plug back into, but that's exactly what we're going to do. Y plus, our first one was a negative 4 equals negative 3. So notice I'm plugging into the equation just as it was. If I add 4 to both sides, because we're looking for the negative, I'm going to get x equal to 1. So my first set is negative 4, 1. And if I do it one more time, we have x equals 1 this time. So y plus 1 equals negative 3, and y ends up equaling negative 4. So 1, negative 4 is my other point. Okay, down to the last 2 here. Same concept again though, right? We want to get one of the letters by itself. The easiest letter for us to get by itself is the x in that second equation. So I'm just going to subtract 3y from both sides. So we'll get x equals 5 minus 3y. And I'm going to keep that first equation intact. Okay, so I'm plugging in for x this time. So I'm going to keep that squared a little bit because we're going to see that minus 5 is still there. Plus y squared equal to 90. But what we're doing is we're rewriting this with that 5 minus 3y inside. So the whole point is that we're plugging in so we can solve for one letter at a time. But you may notice 5 minus 5 is going to cancel out. So we're just going to have a negative 3y squared plus the y squared equal to 90. When I square that negative 3y, that is one term together, so it's positive 9y squared plus y squared equal to 90. And I'm going to combine my like terms. 10y squared equals 90. We divide by 10 to both sides. Y squared equals 9. Now remember, when we go to take the square root, you can't put a square root if you don't put a plus minus, because there's 2 solutions to this. So don't get in the habit of just saying 3. It should be positive or negative 3. And then we just plug in to figure out our answers. So I'll give you a second, pause the video, and just plug in to which either equation you like and figure out what the whole point solution would be. Welcome back. So remember, you plugged in the 3 for y this time because our solutions were y. So x plus 3 times 3 equal to 5. We would have gotten 9, and 5 subtract 9 is a negative 4. So remember to write the points in the correct order. Points are always in the xy form, so we should have negative 4, 3. When we plug in the negative 3, you're going to end up getting x equal to 14. So it's going to be the point 14, 3. Last one here. Go ahead and try this one on your own. So pause the video. I would isolate x in the bottom. That would be my attempt, and then plug that in. Now, there will be a lot of distributing here, so be careful and make sure you multiply everything through. Remember, there's a lot of messy distributing. So we plug the 3x minus 4 into that left parenthesis where x was. That means I'm going to have 3y minus 1 when we combine the negative 4 and 3. When I distribute that, I should have got 9y squared minus 6y plus 1. We also get the y squared plus 8y plus 16, all equal to 17. Combine like terms.